If you have to multiply two matrices, your first goal is to see if they conform to multiplication. And the way you do that is look at their dimensions. The left matrix is a 3 by 3. The right matrix is a 3 by 2. And in case you don't know where those numbers come from, a 3 by 3 means it has 3 rows and it has 3 columns. A 3 by 2 means it has 3 rows and 2 columns. We always specify the rows first. So we say these do conform to multiplication because their inner dimensions are the same. They're both 3. The inside of those two dimensions when you line them up. So since the inner dimensions are the same, we can now know what our final matrix is going to be, what our answer matrix is going to be. It's going to be a 3 by 2. It's always those outer dimensions. So we have 3 rows, and we're going to have 2 columns. So it's good to write that in. So it's kind of hard to see, but I wrote the element locations in our answer matrix. We call this element 1, 1 because it's in the first row and it's in the first column of our answer matrix. This is 1, 2 because it's in the first row and it's in the second column. This is 2, 1 because it's second row, first column, second row, second column, etc., etc. So when you're trying to find what goes here, you always go across the rows in your left matrix and down the columns in your right matrix. So you're never going to use these rows when you're talking about multiplying matrices. Likewise, you're never going to use columns in the first matrix. It's always across the rows, down the columns. So to find this first one, it says go to row 1, right here, and combine it with column 1, right here. Row 1, column 1. And here's how we combine them. You just take the first number in, there we go. You take the first number in each row and column, and you multiply them. -1 times 1 gives me -1. Then take the second number in the row and the second number in the column. 3 times 1 gives us 3. And you add that to the result you just got. And now we're almost done going down the row. We're on the last part of the row and we're on the last part of the column. 2 times 0 gives us 0. So you add those up. -1 plus 3 gives us 2. That's for the first one. Now you go on to the next one. This is element 1, 2 because it's in the first row and it's in the second column. So that means we go to row 1 and column 2. So you can see how those numbers on the side can help you. 1, 2 means row 1, column 2. So to go through this, we do row 1, the first number in row 1, times the first one in column 2, the 2. Then you do the second one and the second one. Those multiply to be -3. Then do the third and the third. Those multiply to be 0. So 2 plus -3 plus 0 gives us -1. And then this guy says, right here, row 2, column 1. So you go down row 2 and column 1. So first number in row 1, first number in row 2, first number in column 1. Those multiply to be 1. Second number in row 2, second number in column 1. 1 times 0 gives us 0. And then the last numbers, 1 times 2 gives us 2. Add those all up, you get a 3, and that's what goes there. And so this is 2, 2. It means you go down row 2 and column 2. Row 2 and column 2. Those multiply to make -2. Those multiply to be 0. And those multiply to be 0, so we get -2 here. Now this guy is 3, 1. And by the way, you don't have to write these in. Once you get good with matrix math, you don't have to write in the element number. So it's just helpful to have a guide. You go through row 3 and column 1. Whoops, up here. 1 times 1 gives us 1. -1 times 1 gives us -1. Oh, sorry, we're supposed to add these. And then 2 times 2 gives us 4. So 1 plus -1 gives us 0, plus 4 gives us 4. And then this is, right here, this is 3, 2. So go down row 3 and column 2. Those multiply to make -2. Those multiply to be 1. Those multiply to be 0. So you get -1. So here's our final matrix.